So this week I thought we'd look at building a sector antenna. Now, a sector antenna is actually based on a design by Samuel Franklin, and sometimes called the Franklin antenna for that reason. And it's a directional antenna, but it has a very, very narrow beam width. Now, the sector antenna is made up of two elements, and it's connected by a center connector. You've got one ground plane element here, and you've got a center element or driven element which is also connected to a ground plane going up here. Now, this antenna works better when it's vertically upright rather than horizontal, and the actual ground plane is pointing down towards the ground. So I thought we'd have a go at building one of these for the 5 GHz spectrum and see how well it performs, and see if we can get some decent gain out of it. So as for materials, when it comes to building this antenna, you're going to need some kind of reflective material, some kind of metal that we can actually use as the back reflector and build most of the antenna onto. It's going to support the actual antenna. Anything else that we put over the top is just a cover to protect the antenna. Now, you could use some circuit board here, this copper clad circuit board, but that's quite expensive. So what I'm going to use today, I've got this plastic strip, and it's flexible but it's still quite rigid, and I'm going to cover that in some aluminium foil, and we can use this as our back reflector. As I've shown before when I've built a bicone antenna, the testing I've done by building one using copper clad as a reflector or aluminium foil or tin or something like that, there's no difference whatsoever on the performance of the antenna. So if you've got some copper clad, but you can use it, but I wouldn't go out and buy it especially to build this antenna. There's really no need. But one thing you do have to remember though, what material you use as the back reflector, is make sure it's thin enough to fit your BNC connector through and hopefully hold your bracket in place as well. So just bear that in mind when you're choosing your material for your back reflector. So we're going to need to find the center of this, so we can drill a 9mm hole through so we can put our BNC connector in there. And the easiest way to do this is to just draw a line from corner to corner, and then where the cross, that will give us our center. Now it's a better idea to actually drill the hole before you cover this with aluminium foil, because although you stick the aluminium foil down, it will still tear where the drill bit is rotating, because it's still quite fragile. So drill a hole first and then we'll cover it with some aluminium foil. So the hole's drilled through now, and what I've done, I've just cleaned the front of this with a little bit of rubbing alcohol to get it nice and clean, and I'm going to use some spray mount on here and then cover it with some aluminium foil. So also, instead of using this, there's some aluminium roofing tape you can buy. That's it's about £6 a roll from what I've seen, and you can use that instead of this. It doesn't matter really, as long as it's metallic. So then, using a sharp craft knife, just go down the sides and cut it away. And as for the hole, you use your finger and you get an outline of it, and what we're going to do, we're going to put a cross, because we actually want the BNC connector to make as much contact with this as we can, because obviously we can't solder onto this. So our BNC connector comes with this little metal ring that we can solder onto, and what we're going to do is we'll place that on with the nut and everything, and we can solder our ground plane onto this metal ring, and then all the body of the BNC connector plus this ring makes contact with the silver foil. So that's how we can make contact with our ground plane without using copper. So we're going to put the BNC connector in place, and what I'm going to do is the BNC connector is going to actually hold this little bracket in place as well. So I've drilled a couple of 9mm holes through this one, and that'll give me a hole big enough to put some kind of tripod through, and this one will just hold in place with the BNC connector. So the BNC connector is in place, and this little solder tag here, I've bent it out at a right angle to give us a nice position where to solder on our ground plane to, and really carefully tighten this nut up so we don't rip the actual foil, and the bracket is in place, held on at the back, so it's all one piece. So as for the copper wire that I'm going to be using for the element on this antenna, I'm going to use some of this 10 gauge wire, and it's quite thin and quite fragile and flexible, so it'll be okay with this antenna though, because we're going to put a cover over the top to protect the element so it shouldn't get knocked or anything like that, so it should hold its shape. But normally I use this 18 gauge wire when I've built 2.4 gigahertz antennas in the past, and here is a prototype of one of these antennas that I've been testing on the 5 gigahertz all this week, and I've actually used this copper wire. Now I've built another one and I've used a thinner gauge wire, and I seem to be getting better performance with the thinner gauge wire, so I'm going to be using this. Like I said, this is about 8 to 10 gauge. I've actually got this out of some household electrical wire. It was the earth part of the cable, but seems to be getting a lot better performance on these 5 gigahertz antennas using the thinner wire. So next we're actually going to start bending and marking off the lengths for the driven element part of this antenna. And basically what we've got here, we've got a half wavelength along there, and quarter wavelength, quarter, and then half again, and obviously carrying on until you got half. So we're going to start building the actual elements for this antenna now, and here we've got a half wavelength, and we've got a quarter and a quarter and a quarter, and another half, and then into a quarters again, and then finish off with half wave here. So it's not an overly long antenna, but again it's really important we get the measurements correct, especially at these higher frequencies. It can make such a difference to the performance of the antenna. So to start off with, what I'm going to do, I'm just going to leave a nice long piece at the beginning here. I'm not going to bother measuring that off yet, and I'm going to put a right angle bend down like that. So we're going to start measuring our first quarter wavelength, and what we're going to do, we're going to bend up in this direction, so make sure that's nice and flush against there, and then get your needle nose pliers and get it flush up against the plastic card, and that way we can get the measurement as close as we can to what we want it. So it makes it a lot easier than measuring each bend each time, and that we can also have errors doing that because it's not going to be the same each time, but this way you can get it as accurate as possible. So that's in place, and hold it, and then we'll want to bend this one up. And also I quite like these needle nose pliers because there's a big flat area here, whereas these ones you've only got that small flat area there, so you can get some really good right angles using these ones. So got our two elements made, so now we can move on and we can start prepping the BNC connector ready to solder these onto. So to connect the actual element to the BNC connector, what I'm going to do is I'm going to add a little bit of copper here to the center to make sure it's as high as a quarter wavelength. You don't have to add a lot of copper here, it's just a little bit too short. And here, where we're going to tie in our ground, I've got a piece of copper here, and measured there, that's exactly a quarter wavelength, but I've left the legs long, and once I've soldered it in place, I shall then measure off and trim those to a quarter wavelength. So what I'm going to do, I'm going to measure off and cut all these to length now. Now make sure that you use the flat part of this reflector and you haven't got it up on the nut, because that can make a 2mm difference. So nice and flat there, and then cut it off to length like so, and do it with the center one and the one on this side as well. So what I've done here, I've got some foam, and it's a sticky back foam, and I've put 2 strips along here because I want to isolate the actual elements from this back reflector. Now when I've made these antennas for 2.4 GHz, you've got a little bit more room, and I've put some little plastic connectors at the base here and actually glued them on so it's isolated, but we're only talking a millimetre here on the 5 GHz spectrum, so this foam here is going to isolate the bottom of these, and then I'll probably hot glue them to the base of that foam. So what I've done, I've now trimmed these to size, so we've got half wavelength here on this side as well as that side, and I've pre-tinned the ends of these and pre-tinned these, so it's going to be a lot easier for us to connect those up. Now this one here is going to be connected to the center element and the ground here, so I've put some tin a little bit longer along that piece, and this one will just be connected up to the ground here. Now I'm going to try and do it at this angle if I can, so it hopefully we'll get a better shot on the camera. So I am working backwards. So we soldered the center one on first, and the shield. It's in place now, and I'll probably hold that down with a little bit of hot glue, and we'll go in and we'll straighten that element out. So the element's actually in place now, and it's insulated by this foam from this back reflector, and I've just put some little dobs of hot glue in there just to hold it down and in place. That should be plenty strong enough. Now what we need to figure out now is how we're going to protect all this from any knocks or bumps or the elements. So what I've got is I've got this 36mm waste pipe, and it's just a plastic pipe, and I think it's pretty standard. So what we're going to do is cut that off to length and then cut it in half. So we've cut that in half, and it fits nicely over the top of the elements like so. And what I'm going to do, I'm going to make some end caps out of some wood, and I'm going to epoxy all this down, and it's nice and secure in place, and then we'll look at giving it some paint. So one last thing to note before we actually put the cover on: this antenna works better in a vertical position, and also with this ground element here facing down towards the ground, and this one upright. So what you want to do before you put the cover on is just make a little mark on the back where the bottom is, sort of thing, because this is the bottom of the antenna and this is the top of the antenna, in that position there. So in the end I made some end caps out of some plastic, the same plastic we made this back out of, and I've just roughly cut it out. And what I'm going to do, I'm going to epoxy it to the end and then trim off all this extra here, and then use the contour of this with a sanding block to finish off shaping the curve to make it look a lot neater. So here is the finished antenna. I've given it a coat of silver paint, as you can see, but I've also put a black line here, and that represents the top of the antenna, because if you remember what I said earlier, this antenna works best in a vertical position with the actual ground plane pointing down towards the ground. So I think all that's left to do now is give it a bit of a test and see what kind of performance we get. So I'm testing this antenna against the stock rubber duck antenna that came with the Alpha card, and at the moment the actual stock antenna is not picking up the 5 GHz signal at all. Remember, my router is a dual band router, and it broadcasts both signals at the same time. But what I've done, I've opened up 2 windows here, and I thought it'd be good if we can compare how, when we connect a 5 GHz antenna up, what happens to the 2.4 GHz signal here, and see how well it picks up the 5 GHz signal over here. So I'm expecting to see this test 2.4 GHz signal drop right off considerably, because we're connecting an antenna that's not tuned to that frequency, and hopefully the 5 GHz signal will pop up and we'll get a nice strong signal from it. So what I'm going to do, I'm going to swap out the antennas now. So the signal will drop off while I do that. So that's the antenna connected, and straight away here we've got the 5 GHz test signal, and it's coming in at around 78% there, but the 2.4 GHz one has dropped right off there. It's hovering at the low 20s. So we'll put that on a graph. You can see how that's dropped off in performance. But the 5 GHz one, we're now getting a nice strong signal through. So I thought that'd be a good example of the different kind of signal you can get by actually using a antenna that's tuned for that particular signal. And also remember that this antenna as well works a lot better if it's up on a high elevation, and it's angled around 30 degrees and pointing towards the actual access point. I'm sure that if I could get this up on the side of my workshop here, quite high up, then we should get into the 90s quite easily. It's already going to the 90s now, so I'm sure if I got it up on a high elevation it would do a lot better. So I hope you enjoyed that video, and if you did, please give it a big thumbs up, and I'll see you next time.